Alright, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, student. How are you today?
Fine, sir.
Good.
Fine. We are good, sir. Good.
Thank
How
you.
about you, sir?
I'm fine, thank you. Alright, as usual, before we start our lesson, let's pray first. Pray begin. Amin. Okay, please everyone, if you don't have any problem with your connection and with your camera, can you turn on your camera so I can see your face? Okay, one student have a problem with the connection, no problem. Okay, as usual, let's start with the attendance. I'm going to share you the link of the attendance. Please, everybody, fill in the attendance first. Okay, please check your chat room and fill in your attendance list.
Where's the attendance list, sir?
In the chat room. Oh, sorry. Sorry. Now, in the chat room. Can you see? Okay. While you're filling the attendance, let's open the PPT so we can start the lesson now. Okay. All right. Welcome to Chemistry Lesson 5, video conference lesson today, 28 July 2020. We did this. Still today, we are going to continue with the scientific methods. I think you already know what we are going to study today. And please prepare your notebook, your pen. If there's something that you want to write regarding to my explanation, you can write. And I gave you in this morning the pre-task, and that's the thing that we are going to learn today. And I checked your pre-task. Most of you did all the answer true. So I think everybody already a little bit check about the topic that we are going to learn today, which is about the hypothesis, theory, and law, right? This is the first part of the lesson. The second part of the lesson also we are going to see another thing still related with the scientific method. Okay, still our objective for today's lesson is about applying the nature of chemistry to the scientific method. Still our topic is about scientific method. This is just the review what we learned last week. We learned about hypothesis. We learned about the step in doing scientific method, isn't it? Somebody writing in the chat. Okay, if you or have problem with connection, you can turn off your camera. Okay, one of the step in the scientific method is formulating hypothesis. And this is the slide that we learned from last week, that hypothesis is meaning temporary answer, the temporary answer, and prediction. And also hypothesis, it must be based on the logic and the fact. And as we know that before we are formulating hypothesis, first you have to think about the theoretical framework of the thing that you observe. And after that, the hypothesis will be proved by the experiment. We talked much about experiment last meeting. We talked about variables, the thing that you have to know in the conducting experiment. So that's all the thing about the hypothesis that we learned last week. Now we are going to see there are something new here, which is about theory and laws. We know that when we are doing an experiment to prove something, to prove your hypothesis, later on that hypothesis that you prove, it will become a theory. And then after that, theory can be a law. Of course, to make the theory to become a law, it is a long way to go and it's difficult. Not everybody can do it. Even scientists in Indonesia, there are many scientists in Indonesia who can make a law. We know that the law is very famous in the world and only some of the scientists can make the law. But for the theory, many researchers from Indonesia also made already the theory. But what is the difference between hypothesis, theory, and law? The hypothesis itself, we learned already, it is just a guess actually, just a prediction, the hypothesis. But remember, hypothesis is just not a simple guess or a simple prediction. It must be based on the fact or based on the logical thing. So it is, we can say that it is an educated guess or educated prediction, not just a simple prediction. So that's about the hypothesis. When we come to the theory, theory is something different with the hypothesis. In the definition, theory itself means it's a comprehensive explanation. So in a theory, there is an explanation about something, and it is very comprehensive. What does it mean, comprehensive? Comprehensive means it's detail, yeah, in deep, yeah, deep explanation, detailed explanation about something. And that explanation must be supported by the fact gathered over the time. So there is not enough, it's only there is one fact. There must be many facts that are gathered over time. As you can see from the picture here, there are many facts that gathered in a time. Of course, we need time. And then after we gather all the facts, of course, in time, then we are going to have a theory, which is a comprehensive explanation, better than the fact that we already know, right? So it is a compilation of the fact that gathered over the time. I mean, it is need time sometime, then it has become a theory, okay? So sometimes theory is need time to make a theory, not only, for example, in a short time. Evolution theory, for example, need maybe 100 years to make that evolution theory accepted as a theory. So we need time for the theory. What we should know about the theory, theory must be explanation of natural phenomenon in the universe. It must be like that. For example, one of the phenomena is the rusting. Okay, rusting is one of the phenomena of the universe. So it can be a theory that explaining about the rusting. Yeah. Later in 12th grade, I told you that we are going to learn the theory about corrosion. What is the theory behind the corrosion? What is the theory that explains the phenomenon of the corrosion? That's the theory. So it is explained about the natural phenomenon. And then theories aren't likely to change. So the theory, generally they are not changing. But the theory can be developed. Ya, theory is not changing, but it's developed. Teori tidak berubah, tapi bisa berkembang. So we have a simple theory sometimes when it is very old theory, it is very simple theory, then it is developed into a better theory. For example, later on in the second chapter, we are going to learn about the atoms. We are going to learn the theory of atom from the very simplest theory of atom into the most complicated theory that we know today. So those are all the theory are true, but it is developed from the simplest one into the most complicated one. And what we should remember, theories are not gases. It is not like hypothesis. Hypothesis is a gas. Although it is not a normal gas, it is an educated gas. But hypothesis is a gas. But theory is not a gas. You have to prove the theory by doing the experiment. Without doing the experiment, you cannot say that it's a theory. So theory must be checked or proved by the experiment. So it is more valid than the hypothesis, because hypothesis is stated before the experiment, but theories must be proved in the experiment. So this is not a guess. That's why theory are different from the hypothesis. So that's about the theory. How about the laws? Laws refers to the rules. So if there is a law, then there is a rule. What does mean rule? Rule is something like this. 1 plus 1 is equal to 2. It is a rule. Everybody will accept this. Nobody say that 1 plus 1 equal to 3. Yeah, because it is a rule. So in this sense, so the law must have a very rigid rules that sometimes it is donated or represented by equation. So equation is important here in explaining the laws. For example, here, one example of the laws in chemistry, this is we call as an ideal gas law, and it is the equation for ideal gas law. P times V is equal to N times R times T. So later we're going to learn what does it mean, this law, but this is an equation that show you the rules of the laws. Yeah? So it's mean that P is showing you the pressure, V is showing you the volume, N showing you the number of mole, R showing you the gas constant, and T showing you the temperature. So according to this equation, pressure will be directly proportional to the temperature. Pressure directly proportional to the temperature. So when the pressure increase, the temperature also will be increased. So it is fixed. It is a rule. According to the ideal gas law, when the pressure is increased, then temperature will be increased. So this is the characteristic of the laws, and it must be explaining you about the behavior under certain condition. If in the theory, so explaining you about the behavior of the particle, for example, or behavior of something in a brief or in the comprehensive ways, in law, the behavior must be measured under certain condition. For example, here, if you want to measure the pressure here, the condition must be there is a volume and there is a number of moles, and there will be R here that also will affect the pressure, not only the temperature. So there must be a certain condition for this. So when we are talking about the theory and the law, I think it's easy for us to differentiate between hypothesis and the theory and law, of course. Hypothesis is different things because hypothesis is only guessing or prediction. But theory and law, they are pretty similar. They are almost the same. They are like very small difference between theory and law. That's why we have to understand very well the differences between theory and law. Here I'm writing some of the things, the differences between theory and law. As a comparison, theories explain why we observe what we do, and law describe what happened. Okay? Now, for example, if we are talking about the ideal gas law here, in ideal gas law, we are talking about the gas. Yeah? The name of the law is ideal gas law. It is about the gas, the behavior of the gas. So when we are talking about the behavior of the gas, why the gas is moving and how the gas is moving when you increase the pressure, when you decrease the pressure, when you increase the volume, when you decrease the volume, all of them are learned in the theory. Okay? the behavior of the gas are learned in the theory. But when the gas is done something, for example, when you press the gas, you increase the pressure or you decrease the volume or you increase the temperature, what happened to the gas? It is the law. The behavior of the gas itself is the theory, but when you did something to the gas, then what happened to the gas? It is a law. So that's the difference. The theory is telling you why we observe, what we do, the explanation about the behavior of the object. And the law is telling you about what happened when you did something to that object. Maybe to make it easier, explain to the difference between theory and law, I'm going to give you one example. This example is still talking about the ideal gas law, yeah, because this is one of the famous law in chemistry. It is ideal gas law. Ideal gas law here is actually coming from one theory. The theory is called as kinetic theory of gas. Okay, in here, in kinetic theory of gas, we are learning about the motion of the constituent atom to the volume, pressure, and temperature of the gas. So we are going to learn how the particle of the gas is moving regarding with the volume, pressure, and temperature. The movement or the behavior of the gas we call as the kinetic theory of gas. Okay, but when I make a relationship between the volume and the pressure, when I make the volume decrease, what happened to the pressure? When I make the pressure decrease, what happened to the temperature? When I make this relation, then this relation is called as a law. And after you make the relation, of course, you can write also the equation, mathematical equation for that one. Okay. So again, to explain this, maybe I'm going to show you a simulation here about the ideal gas law. Then maybe you will understand better. Can you see the simulation in your screen? What you see now in the screen? My presentation or simulation?
A tube of water
You see the
and pressure. Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay, if you see the simulation, okay, I'm going to explain this. Now, this simulation is about ideal gas law and kinetic theory of gas. So we are going to see what is different between theory and law here in this simulation. Now, can you see something moving here?
Yes.
Yes, sir.
Yes, sir.
The red dot is moving, right? The red dot here is show you the gas, okay? So this is gas, let's say gas A. The red dot is gas A. So gas A is moving. So in which one I'm learning this one? In theory or in law? The movement of this gas?
Low,
Low.
maybe.
Theory.
Low.
Theory or law?
Low.
No,
Theory.
no, because there is no
Theory.
combination. There is no
Theory.
relationship. So we learn the movement or the behavior of the gas, the red gas, in it. Can you turn off your microphone, please? Okay, we learn the movement of the gas here, right? The movement of the gas, the red dot here. Of course, in theory, isn't it? We know that according to theory, when I increase the temperature, what will happen? The movement of the particle, you see the difference. When I decreasing the volume, what will happen to volume? If I'm increasing the, sorry, not increasing here. Sorry, I have to give more gas. Okay. When I, for example, heat it, so what happened to the particle? So this is, we learn this explanation in what? In theory or law? The movement of the particle when I heat it or I cool it or I decrease the volume.
Theory.
We learn the movement
Theory.
of the particle in the
Theory.
Theory.
Okay. What theory that explain this?
Gas movement, ideal gas.
Kinetic theory of gas. Okay.
Kinetic theory.
Okay. This is called as a kinetic theory of gas. Okay. So after we know the theory, okay, after we know the theory, now I'm going to make a connection between a pressure, volume, and temperature, volume, and pressure. Now, I know that the formula is P times V equal to N times R times T. I'm going to prove this formula. Now, look at the pressure and the volume. According to the formula, V times V equal to N times R times T. So if the pressure is increased, what will happen to the volume?
The volume will increase too.
Are you sure?
No. It's same.
Look at this formula. If I increase the volume, what will happen to the pressure?
It's same.
Are you sure?
Increase.
They are in the same
Yes.
sign. Mathematically,
Increasing volume equal increasing pressure, sir.
no. Mathematically,
Decreasing pressure. Decreasing pressure.
there must be not directly proportional. They are inversely proportional here. If I'm increasing the volume, then the pressure will be decreased.
Oh, decrease.
Vice versa. If I'm increasing the pressure, the volume will be decreased. Okay, we are going to
Decrease, yes.
later when we are talking about this Gauss law, but I'm going to show you here in the simulation. Let's do the decrease the volume. If I decrease the volume, the pressure must be increased, right? Isn't it?
Yes, sir.
Okay, let's do. I'm decreasing the volume. What happened to the pressure?
Increasing.
Pressure are increasing, right? Now I'm increasing the volume. I'm increasing the volume. What does it mean? The pressure must be
Decreasing.
decreasing. Kebalikan ya. If I'm increasing the volume, the pressure must be decreasing. Let's do it. I'm increasing the pressure. Look at the. I'm increasing the volume. Look at the pressure. Pressure are decreasing. So they are inversely proportional. Berbanding terbalik. Inversely proportional. How about with the temperature? Pressure with the temperature. Now, pressure and temperature. If I increase the pressure, what will happen to the temperature?
The temperature will be increased.
Temperature will be increased also. Now they are directly proportional. Berbanding lurus. If I increase pressure, then temperature also will be increased. Take a look at this. Now I'm going to increase the temperature by heating this one. So the pressure must be increasing, right? Let's see. I'm heating, look at the pressure, it is increasing. I'm cooling, look at the pressure, it is decreasing. So I prove the formula, isn't it?
Yes.
Yes.
Microphone is on, please turn off. If you're not speaking, please turn off your microphone. Okay, so I proved this formula by knowing the behavior of the particle in the theory, kinetic theory gas. I'm learning about the behavior of the particle, but after that, I proved one formula, or I made one formula, which is pressure times volume is equal to N times R times T. So now this formula is become a law, and we call this one as ideal gas law. It is not theory anymore. It is not kinetic theory of gas anymore, but now it has become ideal gas law. Okay, can you see the difference?
Yes, sir.
Okay, good. So this is the first part of our lesson. Let's see, someone is writing in the chat box. Okay, no problem. If you have a connection problem, no problem. Okay, now we move to the second part of the lesson. Okay, let's see what is the second part of the lesson. The second part of the lesson is about the characteristic of scientific method. It is still related with scientific method. when we are doing scientific research and we are following the scientific method step, then there must be some characteristic that we have to know, or some properties of doing research that we have to know. There are many things that we have to do, and we have to mention, we have to follow this characteristic. The first one is critical thinking. So when you are doing your scientific research, you have to think critically. What does it mean, thinking critically? Thinking critically is thinking in depth, not only in the surface of something. So for example, when we are talking or observing the corrosion or the rusting, so not just saying that just normal rusting is always happen in the world, then it's finished. No, it is not critical thinking if you only think like that. But you have to think, if there is a rusting, then what is the cause of this rusting? Why this rusting is happen? What is the cause? Is it the air? Is it the water? Or is it the temperature or the sun or anything that make this rusting? Then you are going to think. So this is critical thinking. So not looking at something with the normal way. Critical thinking is looking something in deep touch, we call that one, critical thinking. Not only in the surface, but you have to deep, mendalam ya, menyelam. Not only in the permukaan. So this is a critical thinking. So if there is a problem, then you are using your brain to critical thinking, then you will find a solution. So this is the first thing that you have to know when you are doing scientific research. The second one is you have to think analytically, analytical thinking. What does it mean, analytical thinking? Analytical thinking is you are analyzing it. For example, if you see the rusting, not only thinking, oh, what is that? What happened to the rusting? What caused the rusting? Is it air? It is water? It is any other thing that make the object is rusting? So not only thinking, what you are going to do is you are going to take the rust you are going to take, and then you are going to analyze it. Oh, the color is like this. Oh, it has become this structure. Oh, the structure is very dirty, for example. So this kind of thing, when you are analyzing it, we call that one as analytical thinking. Okay? Someone is writing the chat. Okay, please. Okay, that's the analytical thing, the second one after critical thinking. And the next one is logical thinking. Logical thinking, what does it mean, logical thinking? Logical thinking means that something that you think, it must be make sense. It must be can be done. Not you are dreaming something which is impossible to do. Then if you're doing the thoughts like that, then it is not logical. So it must be logical thinking that it's match a logic and you can do it. Okay? These three type of thinking is actually as under one part of something. They are very similar to each other. So when you are doing critical thinking, actually you're doing logical thinking inside and also analytical thinking. So they are very correlated to each other, critical thinking, logical thinking, and analytical thinking. What is important here is you are using your brain in different way. You are going to use your brain in deep understanding about something, not only observing in the surface, but you have to make it deep. Yeah, it is called as critical thinking, logical thinking, analytical thinking. The next one is you have to be objective. Now I have a picture here. There are 3 children playing in the tree. Okay, 3 children playing in the park, and they saw a tree. Which children do you think which is think objectively? The left children, the middle children, or the right?
Left.
Which one?
Left.
Of course, the left children objectively. Okay, as you can see here, the lab student is thinking about the tree. Why? Because he saw a tree. So they think about the tree. But the middle children, think about apple. Can you see the apple here?
No.
It's
No.
apple. So he's not objective.
Yes.
He just imagine something. Then he imagined that this tree is an apple tree, but he didn't see the apple. He just imagine that this is an apple tree. So he's not objective. This girl is very, very not objective. Yeah, they're thinking about the money. She's thinking about the money because
Analyzing.
she think that this tree can give what a fruit, and the fruit can be sold, and then it can make money. Yes. In some circumstance, they thinking the middle children and the right children is true, but they are not objective. But of course, it can be true. The middle children, maybe he is true. Maybe this is an apple tree because he know that the apple tree maybe have the color of a leaf green like this. So maybe it is true, but it is not objective. The most objective one is the lab student would think about what they see, what he see. It is the thing that he think. So it is an objective. So in doing the scientific research, we have also to be objective. What we see, that thing that we have to think. Okay. The next one is thinking empirically. Berpikir empiris. Thinking empirically. What is empirically? Maybe I'm going to explain the empirical with this three picture. This three picture is explaining you about the atoms. Do you know atoms? In Bahasa, what is autumn?
Gugur. Musim gugur.
Musim gugur.
Our season in the world, we have 4 seasons. We have winter, we have summer, we have spring, and we have autumn. Autumn is the musim gugur. When the autumn is coming, generally the leaves of the tree are changing the color, and then after that they are going to fall down in the winter. Ya, it's become rotten, membusuk ya di di musim gugur. They are going to fall in the winter. So the one who think empirical, they will think that in the autumn, oh look, the leaves are changing color. So if you're thinking empirically, you will think that, oh, it is autumn. So the leaves are changing color. Berarti kalau musim gugur, apa? Daun akan berubah warna. It is empirically. Okay, it's empirically. But empirical are different from actual. Actual means is not kekinian ya, actual. So now it is autumn. Okay, it is actual thinking. It is autumn. Ini musim semi. Itu aktual. But what happened in musim semi? What happened in the autumn? The leaves are changing color or not? If you say that the leaves are changing color because you see that the leaves are changing the color, then you are thinking empirically. And also something real also happen here. You can see also thinking reality. The reality, for example here, ini musim gugur. Kenapa? Karena perubahan apa? Bumi yang berputar. Sekarang musim gugur. Because of the globe are because of the world are rotating, so now it is autumn. So this is also kind of thinking, but it is not empirically. Empirical is like an objective, yeah. In such a way, it is the same like objective. So you are going to think what you see, what you feel with your hand, what you see with your eyes, what you hear with your ear. That's empirical. Okay. It's related with the objective. Objective is what focus on the object, but empirical is focus on you. You're thinking empirically. And the next one is, this is the last one I think, the characteristic of scientific method is it must be conceptual. So this picture showing you the conceptual thing. Conceptual means that you are going to systematically write something in order. So, for example, if I'm research something, then I have to make this concept. I have to this concept. I have to make another concept. So there must be concepts, not only one. there must be concept that you arrange to be researched, to be searched, so you can know the thing related with the research you do. So you are going to make it systematically, the concept systematically. So scientific research and scientific method also must be like that, must be conceptual. You have to have a clear concept to do your research. Not, for example, you're doing something without any concept. Just do it without any planning, without any written something. So it is not true. So in doing scientific method, it must be written, it must be conceptual. The steps are clear from one step to another step. So this is we call as a scientific method, which must be conceptual. So this is the end of this lesson for today. We have a 5 minute, under 5 minutes. Do you have any question? You can open your microphone if you have any question. So we learn about the differences between the law, hypothesis, and theory. And then after that, we learn about the characteristic of scientific research, which is including, it must be what are those? Let's remember again the characteristic. It must be critical thinking, logical thinking, analytical thinking. It must be objective, and it must be empirical, and it must be conceptual. Those are the things that we learned today. Do you have any question? No. If there is no question, in the afternoon, we are going to do the chemistry lesson 6 and also the post-test. Don't forget, also we are going to have a post-test today. In chemistry lesson 6, in the Google Classroom, we are going to do one assignment. We are going to finish it today. What is the assignment? You are going to conduct one scientific research by showing scientific method steps. But not all the steps that you are going to show. Only 3 steps then you are going to show today. Not all the steps, yeah, only 3 steps. But all the scientific research must be related with the chemistry. Remember, chemistry is everywhere. Last week we learned about that one. Chemistry is everywhere. So you can think chemistry in a broad area. Not only chemistry as a lesson, it must be exploding something or mixing something. No, chemistry is a very broad area, have a very broad area. So you can think everything, but just focus on the chemical side of that things. Okay? It can be something that you see in your home, or you can research in the internet what kind of scientific research you can do. And what you're going to do, you're going to follow this format. First, you're going to identify the problem. What is the problem? You can explain your problem with using pictures. Yeah, using picture, or you write under the picture, write something, explanation about the picture related with the problems. And after that, you're going to formulate the hypothesis with your problem. You're going to solve that problem, formulate your hypothesis. And then the third one, you're going to set the experiment with their variables. You're going to set the experiment and you are going to write the variables. How do you do the experiment? And the experiment must be logic and realistic, because later on you are going to do that experiment. Okay, but not now. Now you are not doing the experiment, just only writing. You are only designing this scientific research, and only this 3 steps. After this 3 steps, the step is doing the experiment, which is we are going to do it later. That's why we're going to do it in the afternoon. And after that, the last 10 minutes, we are going to do the post-test. That's enough for today. See you, because we have only under 1 minute. See you in the next one.
Sir.
Yes? We have only under 1
When
Yes.
when is the date?
Today it must be. Okay?
Today.
Yeah, today in the lesson. In the 6 hour, it must be finished. Okay, see you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.